Okay, so last time
tilting,
we
and then after that.
left off with predicting y hat for a given observation. Petrol vehicle that weighs 300 kilograms has 80,000 kilometers in the environment. Okay, so that's what we start. Okay. And I'm going to now spend a few minutes with the ANOVA table and how to set that up. So you need to understand how to set up the ANOVA or what goes into the ANOVA well. Okay? So that's an important concept in regression analysis. So these are the formulas that go into each of these cells. So degrees of freedom, the total is A minus 1, the residual is A minus P minus 1, and the model is P. And P stands for number of independent variables in the model, in the regression model. And then you have sum of squares, then you divide the sum of squares by the degrees of freedom, you get the mean squares. Okay. And then you divide the mean square error. You divide the mean square error into MSR and you get your F value. Okay? And then you get P value from that. Okay? All right. So now let's look at a problem. Now we have two values given here. So it turns out a partially completed ANOVA, you should be able to populate the rest of the cells with the given information. Okay, so let's look at the problem and see what we can fill from this information. So suppose that one regression model was developed with a sample data of size 50. So n is 50. Okay, so we can immediately say the degrees of freedom for total is going to be n minus 1. That we can fill right away. Okay. The next is that there are 10 independent variables. Okay. But if that was so, then that would be your model degrees of freedom. But then it says 2 of the 10 independent variables are qualitative variables with 3 and 5 levels for the necessary W variable, for which necessary W variables were defined. So you have out of 10, 2 of them are character variables. So there are only 8 interval variables. So these are interval variables. There are only 8. So 10 are total number of variables, out of which 2 are factor variables or character variables, categorical variables. Okay. So there are only 8 interval variables. So how many W variables do you have for the other 2? So the first qualitative variable has 3 levels. So how many W variables do you need for the first character variable? 3 levels, so it must be 2. And there are 5 levels in the second one, so you need 4 W variables. So the total number of predicted variables, the total number of independent variables is 14. So that's what should go in here. 14. All right, so now this is going to be the difference between 49 and 14. So now we can divide the degrees of freedom into sum of squares to get our MSE. So that would be that divided by the degrees of freedom. Okay. And sum of squares will be, so the mean square is sum of squares divided by degrees of freedom. So sum of squares should be that times degrees of freedom. Then we have the F value, which is MS_R divided by MSE. And once you have that, then this will be F dot this dot RT of the F value, comma, the numerator degrees of freedom, and then the denominator degrees. So that will give you the P value. Okay. Oh, it's very close.